Hello everyone and welcome to my channel. This is the A+ Tutor. Today we'll be going over multiplying polynomials. To multiply polynomials, use distribution, then combine your like terms. Let's look at some examples. First, let's look at a monomial times a polynomial. Remember, a monomial simply is a number or a product of numbers and variables with an exponent. If you want a review on basic polynomials and monomials, check out my video on adding and subtracting polynomials, linked below. We have 4 times y plus 1. To multiply this, we're going to distribute the 4 to each of the terms within our parentheses. So our 4 will get multiplied by y, and 4 will get multiplied by 1. So that equals 4y plus 4. Let's say we have 6v times 2v plus 3. We're going to distribute that 6v to each term within our parentheses. So we have 6v times 2v and 6v times 3, and we get 12v squared plus 18v. Next, let's look at a few examples of a polynomial times a polynomial. First, we have 2n plus 2 times 6n plus 1. We need to distribute every term in the first polynomial to every term in the second polynomial. After distribution, we have 2n times 6n plus 2n times 1 plus 2 times 6n plus 2 times 1, which gives us 12n squared plus 2n plus 12n plus 2. From here, we combine our like terms, and we get 12n squared plus 14n plus 2. Let's look at another example. We have 3m minus 1 times 8m plus 7. We're going to distribute every term in the first polynomial to every term in the second polynomial. So we have 3m times 8m plus 3m times 7 plus negative 1 times 8m plus negative 1 times 7. Multiplying that out gives us 24m squared plus 21m minus 8m minus 7. We combine our like terms, and we get 24m squared plus 13m minus 7. Let's take another example. We have 7k minus 3 times k squared minus 2k minus 7. So now we have a binomial times a trinomial, but the same rules apply. We still need to distribute every term within our binomial to every term within the trinomial. So we get 7k times k squared plus 7k times negative 2k plus 7k times negative 7 plus negative 3 times k squared plus negative 3 times negative 2k plus negative 3 times negative 7. This gives us 7k to the third minus 14k squared minus 49k minus 3k squared plus 6k plus 21. From here, combine your like terms, and we get 7k to the third minus 17k squared minus 43k plus 21. Now say we had a trinomial first and a binomial second, like this example. n squared plus 6n minus 4 times 2n minus 4. Again, the same rules apply. All of our terms in our trinomial will be multiplied by all the terms in the binomial. So we get n squared times 2n plus n squared times negative 4 plus 6n times 2n plus 6n times negative 4 plus negative 4 times 2n plus negative 4 times negative 4. Multiplying that out gives us 2n to the third minus 4n squared plus 12n squared minus 24n minus 8n plus 16. And our final answer becomes 2n to the third plus 8n squared minus 32n plus 16. Now, let's multiply a trinomial times a trinomial. Let's take 60 squared minus 60 minus 5 times 70 squared plus 60 minus 5. Our 60 squared is going to go to every term within our second polynomial. Minus 60 will go to every term, and minus 5 will go to every term. That gives us 60 squared times 70 squared plus 60 squared times 60 plus 6d squared times negative 5 plus negative 6d times 7d squared plus negative 6d times 6d plus negative 6d times negative 5 plus negative 5 times 7d squared plus negative 5 times 6d plus negative 5 times negative 5. Multiply that out and you get 42d to the fourth plus 36d to the third minus 30d squared minus 42d to the third minus 36d squared plus 30d minus 35d squared minus 30d plus 25. Combine your like terms and your final answer becomes 42d to the fourth minus 6d to the third minus 101d squared plus 25. Let's look at another one like this. We have m squared minus 7m minus 6 times 7m squared minus 3m minus 7. Multiplying each term in our first polynomial by each term in our second polynomial gives us m squared times 7m squared plus m squared times negative 3m plus m squared times negative 7 plus negative 7m times 7m squared plus negative 7m times negative 3m plus negative 7m times negative 7 plus negative 6 times 7m squared plus negative 6 times negative 3m plus negative 6 times negative 7. This gives us 7m to the fourth minus 3m to the third minus 7m squared minus 49m to the third plus 21m squared plus 49m minus 42m squared plus 18m plus 42. Combine your like terms and you get 7m to the fourth minus 52m to the third minus 28m squared plus 67m plus 42. Now, let's look at raising a polynomial to a power. Say we have x plus 4 raised to the third power. First, let's expand this. This becomes x plus 4 times x plus 4 times x plus 4. Let's focus on the first two binomials. By distributing every term in the first to every term in the second, we get x times x plus x times 4 plus 4 times x plus 4 times 4. Multiplying out and combining like terms gives us x squared plus 8x plus 16. Now let's bring down our other binomial of x plus 4. We're going to take the product of our first two binomials and multiply that by our last x plus 4. So every term in our first polynomial will be multiplied to every term in our second. This gives us x to the third plus 4x squared plus 8x squared plus 32x plus 16x plus 64. Combining like terms gives us our final answer of x to the third plus 12x squared plus 48x plus 64. Thank you so much for watching. I hope you enjoyed, and please comment down below what other topics you'd like for me to go over. See you next time.